Let's begin today's lesson by once again reviewing some old school circle facts. At the beginning of a previous lesson, we reviewed some middle school general math about circles. We learned how to do something called card because it's very helpful to understand that if you have given the circumference, given the area, given the radius, or given the diameter of a circle, you should be able to quite easily find the other elements. Um, so just before we continue and review that really quickly, before we get to the important part of today's lesson, which is the area of sectors, let's review some of these basics. Remembering, if we look here on the right side, that a diameter, which is a chord which goes through the center of the circle, will always be equal to twice your radius, or 2 times your radius, or 2r. And if we would go in the other direction, we need to remember that the radius is always equal to half of our diameter. There's a 2-to-1 ratio there. So given either one of those, it should be pretty simple to find the other. Now, with circumference, the length of the line that it draws around the circle, the orange line in this picture, will always be equal to whatever your diameter is times this funny irrational number that we often use with circles, pi, which is approximately 3.1415 ... It goes on forever. So we like to keep it in terms of pi. So if you just connect or multiply the diameter times pi, that is your circumference. Now, since we often look at the diameter as just twice your radius, we often also look at the same exact formula as 2 pi r, which is exactly the same as diameter pi, because twice your radius is your diameter. On a Regents exam, I believe the given formula is 2 pi r. And then we get to the area formula, which is super important for today, which is going to be your radius squared times pi. Or, as we learn it very early in our mathematical lives, the area of a circle is pi r squared, also given on the Regents reference sheet. So given all of this information, what we should be able to do quite easily is, given any of these elements, find the other three. By writing card on the side of my paper, it's just a very helpful way to organize my numbers. So here, the radius is 3. I know that my diameter is twice my radius, meaning it must be 6. I know that my circumference is whatever my diameter is times pi. And I know that my area is my pi r squared. Well, my radius squared is 3 squared, which is 9 times pi. Please try to remember that the circumference is not the same as the diameter. The diameter is just, say, 6 centimeters in this particular case. The circumference would be 6 times pi, which is, if you remember, a number a little bit bigger than 3. So I know that the circumference would be at least 18, because 6 times 3 is 18. I know it's going to be more than 18, but we're going to leave it in terms of pi today. The next problem, I write down my card. I can see what they're giving me is my diameter. I know my radius is exactly half of my diameter. And I know that my circumference will be, well, whatever my diameter is times pi in terms of pi. And I know my area will be whatever my radius is squared times pi. So as you can see, I use card as just a very, very simple way to take any piece of given information about a circle and find all of the other basic components. Here, even if we're given circumference, which we are in this particular problem down here as 16 pi, well, if they give it to me in terms of pi, all I got to do is divide out that pi to get my diameter. And I know that my radius is going to be half of my diameter, and that my area will be my radius squared times pi, 81 pi. And finally, given, in this case, the area, right, the whole area of the circle, all of the space inside as 49 pi, I remember here, I'm going to do something which you're going to see a lot today. I remember that the area of a circle is equal to pi r squared. Well, here I'm going to substitute my area in there, which is 49 pi is equal to pi r squared. And one thing you can always do, and this will be very helpful in the future when you have long equations that are just products on both sides, that you have 49 times pi is equal to pi times radius, right? Because all radius squared means is radius times radius. So it's really just products here. Well, if you see a constant on both sides of an equation, you could just divide them out, right? If I divide by pi on this side, they both cancel out. So you can actually just cancel out your pi's here. What you end up with is 49 being equal to your radius squared. And then you just do the square root on both sides, and you get your radius is equal to 7. I know you could have done that in your head, but it's just something you're going to see me do a lot in the very near future. And if the radius is 7, my diameter is 14. And if my diameter is 14, my circumference is going to be that same number times pi. So this is kind of old school math, and just to practice this a little bit more and how you might see it in the near future, let's just do a review of carding up here. What is the area of a circle whose diameter is 10? I'm just going to practice my little cards here. So I'm going to write a little card out here. They're giving me the diameter, which means I know that my radius is half, which is 5. I know my circumference will be my diameter times pi. But if you remember that the area is equal to your pi r squared, we know that our radius squared is 5. 5 squared is 25 times pi. Since the answer right here was in terms of pi, that was simple enough. And once again, down here, what is the area of a circle whose circumference is 8 pi? I'm going to practice my card. They're giving me the circumference in terms of pi, which means I can just remove that pi to get my diameter, cut it in half to find my radius. And if I remember that the area is pi r squared, my radius squared is 16 times pi. 16 pi would be the area, right? Easy enough, old school math. Well, let's see what a sector is and how we're going to relate this information to finding the area of these sectors. But before, I have 2 more quick problems. Actually, I remember I put these problems in here because I just wanted to show you the alternate method that I was using, remembering that area is equal to pi r squared, and they're giving the area and they want us to find the radius. I'm just going to substitute that in there. 121 pi is the area of the circle is equal to pi r squared. Again, you're going to see me do this a lot when I'm working quickly with these types of equations. Cancel out the constant pi, and you're going to get 121 is equal to your radius squared, which makes it a really simple equation to solve. That 11 is my radius. Radius would be equal to 11, right? Yeah, and if you wanted a card, you could have just as easily put the 121 pi there, get the radius of 11, diameter of 22, and a circumference of 22 pi, for those of you who are still using your card. And here, 25 over 4, sometimes, yes, we do have fractional radii. So I'm just going to remember that my 25 over 4 pi, being my area, is equal to my area formula, which is pi r squared. Again, my pi's are going to cancel out. I'm going to have 25 fourths is equal to my radius squared, square root, square root. Now, one thing that some of you might not know is that when you square root a fraction, we did learn this in algebra, it really means the square root of the numerator over the square root of the denominator is equal to, that cancels out. and they both happen to be square numbers. So the square of 25, I'm going to go in this direction here. Sorry, running out of room. That I'm going to get the square root of 25 is 5, and the square root of 4 is 2. And that'll be equal to my radius, 5/2. Okay, so now we should be ready to move on to what is a sector. So here's the definition. Sector of a circle. A sector of a circle is the portion of a circle enclosed by 2 radii and an arc. It resembles a slice of pizza. Well, we've spoken about this several times because often when I ask what shape is a slice, many people want to say it's a triangle, but technically it's not. But we do know, for example, that if we take this first circle here, and I'm going to divide this circle into the way that we normally slice a pizza, which is how many slices? Well, if it's a large pizza, I'm going to separate it into 8 slices, right? So if you just take one of these slices out here, you would see that that shape that I just removed from this circle is formed by 1, 2 radii, which are going to be congruent because all the radii in a circle are congruent. And this last side is not a straight line, so it's not a triangle. It's a part of the circumference. And we've learned many times that the name of the part of a circumference is an arc. So it's an arc and 2 radii. And often, while we use r to talk about radii, we usually use the letter s to talk about arc length. So that's really how that figure is made up of, and that is a sector. Now, sectors can be all different sizes. For example, I could take this circle right here and just divide it into, say, let's divide it into 3. Why not? Some odd number here. And I can pull this out right here, and we can see that this is a sector. Why? Because it's formed by 2 radii and an arc. And finally, last but not least, let's see how many different possible slices we can cut this circle in. Let's divide this one into, I'm going to see what the biggest number is. Oh, 12 is the biggest one they're going to allow me to do. Okay, and you can see that it divided the circle into 12 quote unquote slices. If you pull one out, you can see that once again, that is formed by a radius, another radius, and an arc, making that the definition of a sector. Well, today we're going to be learning, well, how to find the area of these given sectors. So here's a problem that I want you just to try to see if you can figure out by just being logical, just some logical thought. Imagine we had an entire pizza pie, yum, 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 with an area of 100 square inches. You might remember that area from middle school is always measured in little squares. That's true regardless of the shape, whether it's a circle, a triangle, a rhombus, or a rectangle. Area is always given in the most basic unit, which is square units. So we're going to be using that a lot in this unit. So imagine that this whole pie, quite simply, not in terms of pi, so it's just straight up in units, 100 square units, just to make this a little bit simpler. How many square inches would you imagine that one slice would contain? Well, we do need to make an assumption here. And the assumption that I'm going to make before you think about this for a couple seconds is that this is a large pizza, and therefore we're cutting it into the most typical division of a pizza that is large, which is 8 slices. So I'll do that for you here, just so you can look at it. Go ahead, pause your video and think about that for a moment. Okay, well, some of you might have come up with my most popular answer, which is, well, there's 8 slices, Mr. Frank, so why not just take our 100, which is the whole pizza, and just divide it into 8 slices. And that would give me 12.5. And that would be absolutely correct. And it's really the main idea is as simple as that, right? We divided a whole entire thing of 100 into 8 units, so that's straight up division. That was in square inches, so I'm going to finish this off by saying that it's 12.5 square inches. You can even see if you looked on this picture, you could see that there's 1/8 drawn there. So one thing that you might want to remember is that a slice of a large pizza is 1/8 of the entire thing. So dividing by 8 is the same thing. I kind of like to multiply. It's really would be the same thing if you had said, well, what is 1/8 of, which means multiply, of 100, which would give you the same exact answer, 12.5. And it's really this model that you're going to see happen more when we are finding the area of given sectors. Okay, let's look at some very, very basic sectors that exist, and then we'll look at any sector that could exist. Well, let's look at the first one. The area of a sector of an entire circle. Well, we already know that, right? An entire circle is an entire circle. The area of a circle is pi r squared. We all know that's our general formula for an entire circle is pi r squared. Well, what about a semicircle? Well, a semicircle, by definition, means it's half of the circle. So if your sector, if you just take a pizza and cut it in half, you're eating half of the pizza. So quite simply, the formula for a half circle would be 1/2 of the pi r squared, 1/2 of the whole circle, right? That's just common sense. You would take the area and divide it by 2 or multiply by 1/2. Same thing. And how about a quarter of a circle? That's as if you took a whole entire pizza and just sliced it into 4 slices, right? It's a quarter of a circle. So quite simply, that formula there would be 1/4 of pi r squared, 1/4 of the area of the entire circle. But how do they come up with those fractions? Well, that's kind of obvious as well. But let's just take a look at the whole circle. And let's look at something called the central angle, right? We're going to go back to the angles inside a circle. Any angle that has the center of the circle as its vertex is the central angle. And if we're looking at a whole circle, the whole entire angle is the whole circle, which is 360 degrees. And we know that 360 degrees out of the whole circle, which is 360 degrees, is equal to 1, right? What they show right here, which meaning that you have a 1 in front of the pi r squared, which is just the general form, the general equation of the area of a circle. But what about a half a circle? When you have a semicircle, the central angle is 180 degrees. So if you put 180 degrees out of the whole circle, which is 360, and you put that in your calculator and hit math, enter, enter, it would be equal to 1/2, which is why it's 1/2 pi r squared. And likewise, if you looked at a 90-degree central angle as the angle of your sector, you would put that angle out of 360. You can put that in your calculator, math, enter, enter, and it's going to simplify to 1/4, which is why we have 1/4 as the coefficient to our pi r squared, 1/4 of the area of the circle. Well, how does this work for any central angle? Well, I'm not going to look at this one over here, so I'm going to cross that one out for today. Today, we're going to look at this formula right here. And in this particular picture, they're using n degrees as the amount of any sector could have, right? Any given sector could have any amount of degrees. I usually use theta instead of the n, but let's just look at theirs, and I'll write it again underneath with the theta the way I usually write it. Well, this right here is going to be your formula for any given sector. So I often like to write the area here is any amount of degrees out of 360 is going to give you the fraction that you're looking for of the whole entire circle, which means that you're going to multiply it by the area of the whole circle. Now, I like to write my sector formula like this. The area of a sector will always be equal to the central angle of the sector over 360. that's going to tell you what part of the whole you are looking for. And you're going to multiply that times the area of the whole circle, right? Now, the area of that whole circle, area of the sector, is equal to your central angle out of 360. You either have the area of the circle or you have to calculate it by doing pi r squared. So either of these versions will work in most cases. Let's take a look at some problems. Okay, the first two are pretty straightforward because in both of these cases, they're giving me the area of the circle, and they're giving me the area of the circle in a non-pi number that's really easy to work with. So for these first two questions, I'm going to use the formula that looks like this. The area of a sector would be equal to whatever your angle is of the central angle of the sector out of 360 times the area of the whole circle. And then you'll find that part that you need, right? So in this first problem here, it's giving me the central angle. So I just need to add the area of the circle. So I can just plug them in quite simply. The area of this sector will be equal to my central angle out of 360 times the area of the circle, which in this case is 60. Now, I could just put that in my calculator and get the answer without a problem. However, I want you to start getting used to identifying what part of the circle is particular angles are. So a 30-degree central angle in a circle would mean, I'm going to simplify this right here. You could put it in your calculator, 30 over 360, math, enter, enter, but quite simply, these zeros cancel out. 3 over 36 is 1/12. So really what we're looking for in this problem is what is 1/12 of 60? Well, 1/12 of 60 is equal to 5. 5, we don't have the type of unit, so I'm going to put 5 square units. Now, I just want to give you a visual here of what we just did. A visual would be like this, right? So if I'm just going to take a circle here. Let me fill it in with some color to make it look nice. Make a yellow circle. Okay, and make a circle here. Okay, so there's a circle, right? So if basically what they said is that there exists a circle, and this circle, the entire area, all of the yellow here is 60 square units, right? And they said, well, we don't want the whole thing. We just want a slice of that. The slice has 30 degrees. Well, that's the same, since we simplified 30 out of 360 to 1/12. That's the same thing as taking this whole circle, which has an area of 60, and dividing it into 12 slices. So we know that the whole entire circle had 60 as its area. They only wanted one of these. And we just figured out that that would be equal to 5. And of course, we want 5 plus 5 plus 5 plus 5 plus 5, or 5 times 12 is going to be equal to 60. And that's really what we're doing here when we're finding the area of a slice, the area of a sector. So here's another one which is pretty straightforward. The area of my sector. The area of a sector is 60. Once again, find the area of, the area of the circle is 60. Find the area of a sector whose central angle is 90 degrees. Well, 90 degrees out of 360, right? That's my angle, times the area, which is 60. Well, we already learned that 90 degrees out of 360 is the same as 1/4 of the entire circle. Well, if the whole circle has an area of 60, 1/4 of it will be equal to 15 square units. Yeah, it's like taking a whole entire circle and dividing it into fourths. If the whole thing is 60, you're going to have 15, 15, 15, and 15, right? Simple as that. Well, let's take a look at 16 and 17, and that's what we'll end this part of the lesson, the first part, with problems that are slightly more complicated, but not that much. So in these two problems, I am going to start utilizing my card, and we are going to be talking about this in terms of pi for both of them. 16. In a circle whose radius is 8, find the area of a sector in terms of pi whose center or central angle is 45 degrees. Well, whenever I'm trying to find the area of a sector, I always ask myself first, what is the area of the whole circle? Can I find the area of the whole circle? This is where the card practice comes into play. So whenever they give me an element of a circle, I like to either on my scrap paper or on the side say, well, what are they giving me of the circle? They're giving me just the radius. Well, with the radius, I could go straight to the area, but let's just fill in the whole card since we've been practicing that. That means the diameter is 16. It means the circumference is 16 pi. But most importantly for this problem, it means that my area, which is pi r squared, is going to be 64 pi. What I'm really doing is calculating the area of the circle, so I can just substitute that in there. Because remember, you could use this formula, or you could say the area of a sector is equal to the central angle over 360 times pi r squared. But I already calculated the pi r squared, and I got 64 pi. So I'm ready just to substitute that in. So now we could jump to the formula and say the area of my sector is equal to a 45-degree angle out of my whole circle, which is 360, times my pi r squared, which I already calculated to be 64 pi. Now, you might remember from the pizza problem that when you divide a circle into 8 slices, each of those little central angles is going to be 45 degrees. And if you don't remember that from before, you could just as easily, before we put this in the calculator, put 45 over 360 into your calculator, math, enter, and you'll see that that simplifies to 1/8. So that's another good one to remember, that 45 degrees goes into 360 8 times. So a 45-degree angle out of 360 is 1/8 of the whole circle, which in this case is 64 pi. But they do want my answer in terms of pi, which means they don't want me to put pi in my calculator and round this off. They want to keep it exactly in terms of pi, which means I'm just going to multiply 1/8 of 64, which is 1 times 64 divided by 8, or 64 divided by 8, which is 8 pi. So the area of the sector is 8 pi square units. And then finally, the last problem down here, it's a very similar problem where they're giving me the radius in circle whose radius is 12. Find the area of a sector in terms of pi, once again, whose central angle is 60. All right, well, I'm going to card up because I find these problems easier to do to find the area right away. So the radius is 12. Sure, my diameter is 24. Sure, my circumference is 24 pi. But most importantly, it makes my area 144 pi. Good, I already calculated that part of the formula. Now I could just jump into the formula. The area of the sector, which is 60 degrees out of 360, times the area of the whole circle, which we already did, which is 144 pi. So we really just want, if we put that in the calculator, we would realize that 60 over 360 is the same as 1/6 of the whole entire circle, right? It's that slice. I cut it into 6 slices, which means the area of the sector would be, 6 goes into that, 224, and keep it in terms of pi, square units. And there you have it. The area of a sector in 2 pretty basic examples. I hope you found this useful, and if you have, don't forget, subscribe to Mr. Frank's YouTube channel. See you soon, everybody.